In this class, now I am going to explain you conditions for a cubic polynomial if whose roots are in arithmetic progression, geometric progression and harmonic progression. Now let us consider a cubic polynomial equation be ax cube plus bx square plus cx plus d equal to 0. So first now I would like to write a condition for this cubic polynomial equation if whose roots are in arithmetic progression. So okay. So here let us assume the roots of this cubic polynomial be alpha minus beta, alpha plus beta. When the roots of this cubic polynomial equation are in AP, so you would have to consider such roots as alpha minus beta, alpha plus beta. So hereafter, sum of the roots of a cubic polynomial relation alpha plus beta plus gamma equal to minus b by a. Now apply that condition. So if you take their sum, alpha minus beta plus alpha plus beta, now whose sum will become minus b by a. You know this relation. So these two will be get cancelled. So now 3 alpha is equal to minus b by a. Now alpha is equal to minus b by 3a. But here alpha is one of the root of this cubic polynomial equation. Hence you can replace this x by alpha. So here a alpha cube plus b alpha square plus c alpha plus d is equivalent to 0. Now here you got alpha as minus b by 3a. Now replace this alpha by this minus b by 3a. So here a into minus b by 3a whole cube plus b into minus b by 3a whole square plus c into minus b by 3a plus d which is equivalent to 0. Now simplify this. A of here minus power odd number minus b cube by 27a cube you will get. 27a cube. 27a cube. Now here minus power even number becomes positive. Now b square into b cube whole by 3a whole square 9a square minus bc by 3a plus d which is equivalent to 0. Now here in the denominator there are 3 a's, cancel one a. So here after cancelling a what is left? Minus b cube by 27a square plus here b cube by 9a square minus bc by 3a plus d which is equivalent to 0. Now take the LCM for LHS. So 27a square will be the LCM for these four terms. Now simplify here minus b cube plus here 9 3 is a 27 3 into b cube 3b cube here 3 how much is that 27 9. So here a is there, here a square is there, so that here you will get 9abc. Here 27a square d which is equivalent to 0. Now transfer this one to the right side and here these two are like terms. Here how much do you get? 2b cube plus, so transfer this one to the left side, minus 9abc plus 27a square d which is equivalent to 0. Now keep these two terms for LHS only, 2b cube plus 27a square d and transfer this one to the right side, 9abc. So this is the required condition for that cubic polynomial if whose roots are in arithmetic progression. What is that condition? 2b cube plus 27 a square d plus 9 abc. Remember this condition. It helps you while doing the applications based on this cubic polynomial. Okay, in the exam, so the coefficients a, b, c, d, in place of that 4 unknowns, okay, 4 a, b, c, d constants, they give you 3 constants and they will write one unknown value. If whose roots are in arithmetic progression, then find that unknown value. They will make the question like that. In such case, you would have to use this relation 2bq plus 27a square d, which is equal to 9abc. Substitute that a, b, c, d values. Okay, collect from that given cubic equation and substitute here and go for simplification. So we will get our required unknown value. Okay, so next let us learn if the roots of the cubic equation are in harmonic progression. Okay, next I am going to write the condition for the cubic polynomial if whose roots are in harmonic progression. So see here, ax cube plus bx square plus cx plus d equal to 0 is the given cubic polynomial equation. As they said, whose roots are in arithmetic harmonic progression. Okay, so if you replace x by 1 by x in whole equation, then we will get one new equation whose roots will be in AP. Actually, what we people are going to write here, condition for the roots of this cubic equation if whose roots are in harmonic progression. But here what I am doing, I replace x by 1 by x. So simplify this. Here x cube will be the LCM and simplify here a plus bx plus cx square plus dx cube, which is equal to 0. Send the x cube to the right side. So then the given equation will be transformed into dx cube plus cx square plus bx plus a is equal to 0. You got. Then whose roots are in arithmetic progression. So whose roots are in harmonic progression. So as you know, just now we learned, when the roots of the given equation are in AP, we derived this condition. But in the place of A, here what we have got? D, no? Now in this entire equation, see here, 2 into B. So in the standard given one, x square coefficient was the B. But here x square coefficient C. Now replace B by C. 2C cube plus 27A. Here in the place of A, what is there? D. 27D square. Here D. In the place of D, what you got? A. So which is equal to 9. 9 A, B, C means coefficients of first 3 terms. So here B, C, D. So this is the required condition for the cubic polynomial if whose roots are in harmonic progression. You know. Okay. So what is an AP and what is an HP? Actually they said that whose roots are in harmonic progression. I replaced x by 1 by x. I got this equation. As you know, whose roots will be in AP. If these roots are in AP, just now we derived one condition. Just in the place of A, B, C, D here, I replaced by these coefficients. Finally, I got 2C cube plus 27D square A, which is equal to 9BCD. Is the required condition for this cubic polynomial if whose roots are in harmonic progression. Okay. Now let us go to write condition for this cubic polynomial if whose roots are in geometric progression. Right. See here, ax cube plus bx square plus cx plus d equal to 0 is the given cubic polynomial equation. If whose roots are in geometric progression, then we would have to consider such roots as alpha by beta, comma alpha beta. So now take the product of all these roots, alpha by beta, alpha beta. You know the product of the roots. Okay, so minus d by a, alpha beta gamma is equal to minus d by a. You read this condition while you were learning that theory of equation. Product of the roots equal to minus d by a. So same I applied here. I considered whose roots as alpha by beta, alpha beta. So whose product will be minus d by a. Now beta cancel. Now alpha cube is equal to minus d by a. Now make alpha as subject, minus d by a whole power 1 by 3 you will get. Whole power 1 by 3. Alpha is one of the root of this cubic polynomial equation. Hence replace x by alpha, so that you will get a alpha cube plus b alpha square plus c alpha plus d, which is equivalent to 0. Now a into alpha value, students, minus d by a, so whole power 1 by 3 whole cube, plus b into minus d by a whole power 1 by 3 whole square, plus c into minus d by a whole power 1 by 3 plus d, which is equivalent to 0. Now simplify that. This 3 cancel. Now what is left here? Students, here minus ad by a. Here minus power. So here minus power even number is there, then which becomes positive. So that here you will get b into d power d by a whole power 2 by 3 you will get. Okay, right, now come here, minus power odd number becomes minus. So here what do you get? C into d by a whole power 1 by 3. Now plus d, which is equivalent to 0. Now this a cancel. After cancelling a, what is left? Minus d. Here we have one plus d. Both can be cancelled. Okay, I hope you have understood till here. I considered whose roots are in. Whose roots as alpha by beta, alpha beta, when the roots of the cubic polynomial as given as in GP. Okay, so later on what did I do? I took whose product. So you know that relation. Product of the roots equal to minus d by a. So here alpha cube equal to minus d by a I got. So I made alpha as subject. Now as you know, alpha is one of the root of this cubic equation. Hence I replaced x by alpha, I got this. Now replace this alpha by this and go for simplification. So after simplifying, so what we people are going to get? Now tell me here, b by, so b into d by a whole power 2 by 3. Now transfer this one to the right side, so that what do you get? C into d by a whole power 1 by 3. Okay? Right, now hereafter take cube on both sides. If you take cube on both sides, here it is going to be b cube and here it is d square by a square. Now here c cube d by a. Now here b cube into d square. D square you can write as d into d. By a square you can write as a into a. So here c cube d by a. 1a cancel, 1d cancel. Now what is left? See here, when you transfer a to the right side, so b cube into d, now which is equal to ac cube. So this is the required condition for the cubic polynomial equation if whose roots are in geometric progression. What is that? B cube D, which is equal to AC cube. So in this model also, in place of A, B, C, D, they will give you three constants and they will write one unknown value. If whose roots are in A, P, G, P, H, P, then find that unknown value. So this kind of questions will arise. So in such applications, you people have to utilize these three conditions. So okay. So when the roots are in AP, I wrote one condition, and when roots are in HP and GP, also I explained. Thank you.